Hello, hi guys, welcome to Things Tech. And today we'll continue the problem that we discussed in the previous video where we talked about the concept of a sliding window, and in that we solved some easy to medium question. Today we'll try to cover a couple of hard problems. We'll see hard maybe. Okay, so without wasting the time further, let's jump to the problem directly. So So today's problem is mainly this is the first problem. Substring with a concatenation of all the words. So you're given a string as in the words, and all the words will have a same length. And the concatenated string is a string that exactly contains all the string of the any permutation of the words. So here the example is given A B C D E F. It can be C D E F A B or A B C D E F or any combination, right? But we have to concatenate all the words basically. Okay. Once you concatenate, then you need to find the given as whether that substring is present or not. If yes, then find the starting index and just return the list of all the starting index, right? So let's take one example of foo bar man. Okay, let's try to go there. Right. So basically, example goal is find the all indices of a substring in a given string. So let's say you're given a string foo bar the bar foo. This is a string, and the words which is given is foo and bar. Okay. Now what is asked is with this word you can generate uh, any substring by uh, generating all PNC permutation and combination, right? So let's say for this, what sort of permutation combination is possible? Foo bar can be one string, it can become, right? Another string it can become is bar foo. Anything else is possible because you have it's like you can assume this is 1 2, either 1 2 or 2 1, because you have to take all the words also and you have to concatenate in any order. So if you want to take 1 and 2 as in just giving in terms of number, either 1 2 or 2 1 is the possibility even if you do all the PNC, right? So let's take a further example for this permutation combination to make it more clear. You have a foo bar, and let's assume you have a something like, let's say, LXY. Okay, so then foo bar LXY is the one combination because it is mentioned you have to pick all the words, but you can concat in any order. Another can be bar foo LXY. This can be another string. Then when you have fixed foo bar, then you can move these two, either LXY or bar. Once you have fixed bar, then foo LXY or LXY or foo. Similar, you can fix one and move other. Similar way, you can generate all the combinations, right? So what you're trying to say is either one of the combination can be present in your string S. So let's say foo bar is there and bar foo is there. So this is the string given. So I see 0th index is the one where I can see foo bar is possible, which we found here. And bar foo is also there, right? So which is we can build using foo and bar. So that is at a 369. So 9th index, right? So 0 and 9 is the answer for this. So if we see what is the answer for this, 0 and 9, right? Similar, if we go take a more example to make it more clear, right? So let's take, if there is no, let's say this is an example word good, best word. So I can see a word and good. Good is there, but what you can make out of this? Let's take this example, I think, to make it more clear, right? So what is given is you have a word good, best. This is the word which is given, and another one is the best word, good, best word. Okay. Okay. But the S string which is given is word, good, good, okay, best, and word. Okay, this is the string which is given. These are the words. So with this, right, what sort of things are possible, right, that we have to see, right? So I can see for the word we have a two frequency. Frequency in the sense that two time words in word has come, good and best. So you can combine word, word, good, best. There can be multiple possible combination. One you fix, then move others. Then two you fix, then move others. Similar way, you can generate all sort of possible combination. But this in this string, you have to find which sort of word is possible. Simple math, simple like analogy. If we take right, avoid math like simple basic. If you look this string right, do you see anywhere you have all the four words that you will generate? Because at that all the four words, what it will have is two word, like two times these word and one time this good and best. So till this it's not possible because good has come two times, right? So this is invalid, right? But this is a one of the possible good best word, but the word two time is never coming right together. So this is not possible. So the answer is empty string. So why we say कि this is not possible? Because I can't see in any of the substring where the word is coming together, right? And if word is coming together, then the good frequency is higher than the what is present in my word, given word, right? So if we take full, so word is two time, but the good is never been two time in this, right? It is one time only. Best is also one time, but here coming two times. So I can't, I'm not able to find any substrate, right? That's what it's trying to say, right? So yeah, I think this is clear. So pretty much now let's think about the approach, how we will try to. So you have given a, what all things you have? You have words, right? So words is, let's take example of word good. Let's try simple and the best, which is possible, right? These are the three words. What it says is all the words, all the words will have a equal size. So what it's trying to say is in the words list, this word is 4 length, this is will also be, so all will have a 4 length. And the S string is given to you. So this can be like word. Another example I'm taking so that I'm just explaining what sort of approach you can take. Let's try perfect, good, and the word good best and good word. Let's try this. This is a string you have. Now, how you try to see this approach, how you will try to solve this. So if you think, right, this is a concept as we know, it is a concept of a sliding window, but logically how it will come to your mind, I'll come to it. But you know currently it's a concept of sliding window that we are trying to solve, right? This problem is tied to sliding window. So do you see anywhere using a sliding window we can think of, like we can think on trying to solve this? So let's try to think in that direction, right? So let's say word good best, right? So what we'll do is first you have a word, right? So I see word is there, good is also there, best is there. So this is becomes a one, right? This becomes a one, right? So in all words it takes basically because in real like simple brute force approach would have been like you generate all the combination of this and just look for the substring for each of the string, and just whichever string is matched, right? So you'll be able to figure out like which are indexes and which string is matched, and just at the end you'll have answer. But generating a possible sub like combination is higher on the complexity side, right? So we'll not take that side of our approach. We'll try to think in simple approach where without generating a combination of all PNCs, right? Is there any way we can try to solve this, right? So let's think in that direction. So let's say I just thinking. I start from zero, right? This is a simple sliding. In the previous problems also, sliding window is like one pointer you have, that will two pointer you'll have I and j. So I you'll move and then you'll keep it. So once you reaches to till your goal, right? So let's say word good best all matched. What you do is you'll try to see this is a one of the index I found where all my combination is matched, right? Right. So this becomes a zeroth as a one of the index. Then what you try to do, you slide. This has become, now what I want is I have to move one word, right? One word I meant is I have to move to the, like, squeeze the window. J pointer I'll move, right? So that I can find another substring which is possible to generate via the given words, right? But here you can think in simple terms is like, let's say in a starting you try to find a frequency of the words. Word as a 1, good is 1, and best is 1. Just try to do it in a map, right? So that this will help in your when you will be iterating it, right? So let's say this time, because you are not able to generate a string, so what is the way? You'll try to see whatever the substring you are visiting, whether how much words you are able to tick. Once you are able to see you have matched all the words, that means that's a perfect. Like you found a substring which has all the words, right? In short. So that's the thinking direction I'm in. Okay. So yeah. So basically you have this frequency sort of a map. Now what you do is you have to iterate, right? So simple basic approach, just not going at a like how we'll try to solve it, just basic thinking. Basically you have to iterate this. You have this frequency. What you can do is you have this word, you traverse till this, yeah, this is matched, this is a like this is our target, and this is you can maintain a current frequency sort of thing. Okay, this word you visited, yeah, word I found 1, good also I found 1 till here. So this point of time I have matched whatever is the current FQ and word FQ, right? It has completely matched. This is a word of the, I would say, substring, right? So this becomes, then you put in the answer as a 0. Now you have to slide. You have to slide as J. J, how you'll move forward, right? That's a challenge we have. So how you try to move J? For moving a J, you have to increment a J, right? So let's say you're starting from W, you can start from O, so there also it can become possible, right? Or, right? Further you have to slide, right? So let's say you start from O, just give an example, right? Then again, you have to, from O, you have to C, right? But starting up from O will have a challenge. Like what is the challenge it will have is you have to negate the one of the word, right? So whatever the current frequency map, right, which you have created, right, won't work, right? Then you have to again recreate. Recreating a word is like completely traversing this string again, which you have already traversed. That we don't want to do, right? So what is a better way? Because if we start from 0, then I don't want to traverse, like if I increment a one word, right? Then whatever the map, frequency map that I've generated, it is a valid if I move word by word, right? Whatever the word size. Otherwise, if I move one pointer, it's no longer becomes a valid, because if you slide, let's say word, good, best, this map you created, for example, this one, right? There's a similar frequency. Now, if you move one word, right, then word good won't be able to exist, because all these three frequency word, let's say, become 0. Then you have to remove this also, because till this pointer. Now it becomes a, so far it's like a 12, then 12 length is string, right? Substring. Now it becomes 11. Now you will not have a 4 size because at then you have to concat, right? The words. So 11 size won't be a valid for you no longer, right? Because it can be either 8 or 12, right? So that's where I was coming. Think like if you start from 0, I equals to 0. If you start from 0, then to make your slide valid, right? It has to move the equal size, right? Not have one pointer ahead like similar we used to do, but here the trick is you have to move in the equals, like you have to like jump every word's length. Like you can't move a one length, right? One size. Basically, otherwise your if you move one size, then your whatever that you have done the computation of the current frequency becomes invalid, right? That's our whole point. So what we do is, let's say if you fix 0, so basically you have the word, this you already have pre-computed. So current FQ is word is 1, good is 1, and best is also 1. Now what I'm trying to say is, for further moving, right? Right, this has become your one of the word, so you have the answer, right? So your answer becomes a 0, but now you have to move, right? Because this has matched, right? Your one of the substring you have found from the like having one of the permutation from the word, right, which exists, right? In short, now what I'm trying to say is here basically you have to move your I. You have the I pointer where now your I pointer is here, right? Best till best you have visited, right? So basically it's at 11, 4, 12, 11, right? Index 0, and J is at a 0, right? Correct. Now, in order to move further, right? Correct. So, in order to move further, because you have the I pointer, because till this point of time you have visited, right? So, next will be 12th only, right? So, your I pointer is 11, J is 0, right? So, now one of the word you have to slide, J you have to slide because you found a, like one of the substring you have found. Now you have to slide a J such that another substring can be formed using the sub part of a, like whatever the existing substring, right? So in this, what I'm trying to say is if you move J with the length of the word, which is nothing but a 4. So 0 plus 4, so you will move, J will become here, and you have 11. Now you take another word, right? So here, what it becomes is your frequency word becomes 0, good becomes still 1, best becomes 1. So far with me, right? Now what I'm trying to say is you have to visit a, so still you are not, now you're not in the, you're not able to find full words, right? Because it's not there, right? So far. Now what we do is we have to visit another word, right? Because now one word is left, right? Because the size of this is 3, right? Sorry, 3 words so far you have visited, and 3 only we needed, right? In the math, from the math. Here you have only 2. Now we have to visit this good, right? So in order to visit this good, what I'm doing is I just see keyword is 0 still, good becomes 2, best becomes 1. Still, it's not satisfying the condition of mine, right? Which is I have the word good frequency is a 1 only in the WFQ, which is nothing but a desired one. But I have a good 2 and best 1, right? So here I have to slide again because the good frequency is more, right? So what I do is the left pointer, which is here I is on the 14, 15, and J is on the 4. So J I have to move further. Same J becomes on 8. So J is now here. Here J, I was here so far. I have to move here. Now this word I have to traverse basically, right? So now what I do is I is here 15, right? So I have to visit another word. So there basically word becomes 1, J becomes swap. So let's keep this as another post this. So word becomes 1 because I'm traversing next, and good is still become because I've sub reduced, right? Like I'm compact, like I've done a J pointer, right? I was doing a slide from the J side, like compressing, or better word would be like keep. I'm trying to slide the J so such that I can get the desired result, right? So this is a good, best is still 1, right? So this word good, best is 1, 1, right? Now what I'm trying to say is word, best, good, 1, 1. So far I have visited all. So this is the string, and this matches the frequency of the WFQ, right? So this is one of the word. So 0 was the one of the answer we had here, right? Now what we add is answer, final answer becomes 0, and the frequency of 3, 6. Yeah, 6. So 0 and 6 is the answer, right? Hope this explains. Now so far what you have seen is we are starting from 0 and then moving with the word length, right? Because that is every word length is a step up for us. Like we are traversing 0, if word length is 4, then 8, right? Then 12, something like that, right? Now, this way we are able to cover the cases where it is able to find from the, let's say, I would say from the 0 with respect to 0, right? Basically, what I'm trying to say is, let's say your example is word good, best, right? In word. So these are the words, right? So we are able to find, right? But because we are moving in a direction where I would say, let's keep this, oh, sorry. Yeah. So we are moving in a direction where, we are moving every time 4 step, right? So this is like, and then once we reach, then we slide. If let's say doesn't match, then it will just move ahead, right? So let's say something like comes man. So man is not matching. So your I was here and J was here. Then I moved till here. J is still here. I was here. Like your 4. It's not matching. So doesn't make J to be here, right? J can also move here. So J can also come at the same, right? Then you can move I to the 4 to 8. Then J can still be here till the time it's matching. If it stop matching, then you have to move J also, right? To find another one, right? Simple. Now, this works with respect to the 0. It works well because like from 0 you're moving 4, 8, 12. But there can be a scenario like I can have a X, let's say many, yeah, right? So I can have a like X, right? Something like X word, good. Just giving example, best, right? Now, if you start moving, right, this is a 4 length, and this is another 4 length, and this is 4. Now you have you like your size of a string, as a string is not divisible by the, basically size of the as a string not divisible by the your word length, then you have a problem. Then you're missing on the some cases. So basically what I'm trying to say here, to handle those scenarios, because you started with the, let's say I0 and then moving like 0, 4, 8, 12. Similar, you can start with the, you have to start with the I1, right? From the 1 pointer also, you can move 1, 5, 9, 13. Similar, dot, 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 dot. Such that, so that, like with the 1, you can divide in 4 until the time you reaches. With the 1, you are able to possibly generate the all the cases, right? Because you skip the 0, right? There. and then I equals to 2 also, like 2, 6, 10, 14, similar 3 till like till the time of the word length, basically 3, 7, 11, 50. So why we need such more iteration, right? Because these are the different starting point it is possible for our word, right? Because word length is a 4 here, right? So you start with a 0 because a string is not guaranteed to be having a equal length of the word length, right? Divisible by the word length. That is not guaranteed. Only guaranteed is you'll have all word is equal length, but the string which is given can be having any length, right? Then in order to generate all combination from your words, right? What you have to do is word length, what is there. So means those can be the starting point for you, like 0 to and like let's say 4 is the length 0 to 3. From there you move 4 step, right? If the 4 is a word length, right? So that 0, 4, 8, and then 1, basically 5, similar way, right? 9. So this way you're not missing on the cases of the where the it's not divisible, right? So that way you're able to generate those phrases, or I would say those words, right? And at the end it is able to come up with a substring which is matching with the word, right? So that is the whole purpose here, right? So that so the for these cases it's still a word, but here answer will have a 1 as an index because the word good best is a still I got it. But if I would have chosen the traditional approach where I just started with a 0 and didn't consider for these cases, then I would have missed the loop for these, right? Where the I can have a different starting point in the string s. So here the answer is a 1 because from the 1 as a starting I can like get a substring which is having a like all the words in that, right? So let's see the code to make it more clear. This hope so far you understood this. So this is a bit tricky question, I would say, but yeah, it's I would say medium to hard, not that hard, but yeah. So let's try to see the code. Just a second. Yeah. Now let's try to see the code. Now what I did is this is a word frequency which I talked about. So in the starting you have the words. So what I did is just like computed the frequency. Because the same word can come multiple times also, right? So each word will know the what is the frequency of it, right? So this is nothing but an answer. These are basically uh, hmm, hmm. So this is nothing but an answer. You can see here, and now I'm moving to here. So this is nothing but your just trying to find the length of the word, right? Because it will be equal across all words, right? And then this is the length of the your s length, right? It's nothing but a string length, which is given to us in that we have to find a substring, right? Total words is nothing but a size, like how many words is possible, right? So those words, how many words are given in the input, basically in short, not possible. This line is nothing but what I'm trying to say is the first loop which I talked about, where we'll have a different starting point. So this is that loop I would say. So which is nothing but a starting from 0 till the word length, because those can be the starting point for a substring, or I would say those can be starting point to find a substring, right? Yeah. So here k is nothing but your basically I would say your I point. Basically k will be your I would say j pointer that we talked about. I is a j here, so don't get confused. So k you can think of like a left, and j is a nothing but a right. So left is nothing but your which used to be like you have to slide, and the right is which is moving with the loop, right? So I started with I and that till the length of a slen. Slen is nothing but a string length, right? And this is nothing but your ln. Ln is nothing but your words length, right? Every time I'm moving in the word length. This current FQ map is in the running time. I'm like keeping the frequency map sort of word, right? So this is I try to find a substring, right? So current I started with a J and length I know always within that. Basically word length I have to find and just try to see whether it already exists in my word FQ map, right? Which is given the words list, right? Map of the words list. And if it finds, it means it's a one of the word, right? I just increment the frequency in my current map also. And the count, because count is the one which will indirectly give me the whether I would match the in like target frequency map with the current frequency map, right? Basically, this is nothing but a current frequency map updated, and then count plus one. This is one of the case where I talked about good comes twice, but we need once in the target. Then we reduce the frequency by the sliding the J pointer, nothing but your left pointer, right? So this is nothing but just I'm finding it. If the frequency is more than just trying to find the K and the length will be the K is nothing but your right pointer. Just you have to slide the right pointer, left pointer, sorry, and then equal to the word length. Every time you find it and just increment it, count you have to reduce and the current frequency also reduce because you are sliding it, right? If at the end it becomes total words is nothing but your input number of the words which is given and equal to the count, then you just push that to answer. Else if it is not in the map, your word FQ map, and if you find some word which is not there, then you just clear your current because that till that time, then because after that word came in between which is not useful, which is not there. That means you can move your left pointer after that word onwards, right? Because though that will make the previous whatever you visited as an invalid, right? Not useful so far. If you include that the word, right? So current FQ, you clear it and you can just move your right pointer to the whatever the J is there with the line because J will already increment once you come out of this, right? Come to the next. And count will also become because this you made it already zero. So you're nothing which you have visited and zero. So at the end, once this is done, then you just are done with this, right? So this is nothing but if you see, right, the complexity of this is the word size, right? Right. So I'll talk about the complexity, right? This first loop is nothing but a word size, right? So word size, let's assume I'll just word size, right? So that is like, let's say you have m words, n is a word, l is a word length, and and we can assume the string length, right? Which is the main string which is given, right? Which in which you have to find the substring, right? So it's like a L, right? So your L is the word length, right? One word length. And then what you did is basically you have divided N divided by L, and then substring you can find a maximum of L length. So it's become N into, right? L into N divided by L into L. So N into L, right? So that's the thing. So I think let's talk about that also. So the time complexity, right? What we did is first we did as M. M is a words number of the words. L is a words length, and S len is a N, right? Which is nothing but a S string len. So what we did is M is first we traverse the M frequency map. Then what we did is L times into N divided by L because we were incrementing I every time by L, so N divided by L into substring maximum you can find this size, so it becomes M into N L, right? So it's a NL I would say because M might be smaller compared to the L. And is there anything that we missed in the this is O of this, but If we missed anything, what it can be, let me see the code. So for this, so there is a clear also, right? So clear is nothing but iterative, right? So that if it can have the m words, right? So like O of m also can be added in the right. So then it can become more also, right? So what I'm trying to say is, uh, if this is, in which case it will become basically this clear is O of m, right? Because you have to clear all the words frequency, right? In short. So let's say this is n divided by l, and you will keep on inserting it, and you have to clear this, right? So when you have added all the words, then one time you have to clear it, right? So that can be, let's assume this also. So what it can have, either let's try to redefine m plus l into n divided by l. Either it can have a l or m. So let's assume it has a m. So it can have a worst if m is bigger. So either n cross m or n cross l you can take. Either way works, right? Yeah, and the time space is whatever the frequency you will keep in this. And that's the only thing that we are mapping it. I think that will be bigger, yeah. So space will be, this is our time. Space is of m. The space is where the m words can have, right? Or m plus l you can take. L is also a string, that substring side. So it is of m, you can assume, right? So this is a space. Yeah, I think that's all about this problem. Hope you understood it. Yeah, it's I would say tricky, but yeah, not that tough. So let's move to the next problem here. This is a bit easier, but yeah, minimum window substring, right? I'll just explain it fastly. It's a straightforward problem. I just say what it tried to say. Whatever we have solved, right? It's correct. It's easy compared to what we solved earlier, but I would say in the previous video we have solved similar sort of problem, but yeah, I'll just explain anyway. Minimum word substring, right? So basically, what it says is you have a string A, B, C, D, E, O, F, G, A, again O, A, B, C. Now you have to find a minimum word substring means is, and you have given a word T, let's say A, B, C, O, right? So basically, what it tried to say is minimum window substring, sorry, not word, it's a window. It's a window. So let's say this is the string A, B, C, D, E, O. Here you can make F also, right? F, G, and G, O, F, A, B, C. Now you see A, B, C, right? So this is the one of the another string. So this string and this is another given string. So you have to find that this T string, right, has a characters. So A is one time, B is one time, C is one time, and O of one time. So you have to find a minimum size a substring which contains all the characters of a T string. So let's say A, B, C, D, E, O. This is the one of the string which contains all the characters of the T string. Another is this. Now you have to return a minimum. So this is a 6 length. This is a 5 length. So you have to return a 5 length minimum one. So which is nothing but a OFBAC because this contains all the characters. O one time, here be O one time, BC one time, BC one time, right? So extra character can come, but you have to minimize such that it has to have all the words, right? So you have to minimize such that all the words, all the characters frequency should match, right? Whatever present in T and whatever the substring that you are trying to find, you have found, right? In short. Such a simple question like simple I0, J0 starting, just you found this, move till this when you maintain a frequency array. Simple, we have solved many questions of such pattern, right? And once the frequency matches, then these are one of the, like you can say, substring you found, and you try to minimize the length and just at the end you return it, right? So basically, let's say you have found till this, so I and J is there, right? So let's say I0, J0, I you move till here, the I becomes here. So here you have found complete string, right? Till here. So till I you have found it, right? Now you have to move, right? So if you move this, then you lose a substring, right? So you have to move forward, right? Because you can't move, right? So till this you can't move. This point you can move. So you move till here. So let's say, yeah. So I was 0, then J was 0. From here, J was 0. I first moved till 3, 6 means 5, right? One of the substring we have found, right? But further we moved. That was a 6 length. Now further we moved, right? 5 minus 0. So the formula is I minus J plus 1 is the length. I is still, J is still 0, I is still 5, right? But J we can't move because if you move J, then you lose that T string character because this A has to be there, right? BC has to be there. So you move till this point. So you have a 6, 3, and 5, 11, right? So you move till 10, right? Then J you can move till 1. So still these are the bigger size. You have the 6 line. You have to minimize, right? So still you can't move, right? J. So you have to move further. So I move to 11, J move to 2 because B you can move now. Then once you reach till C, right? I move to 12, J becomes 3. So 0, 1, 2, 3 here till here, right? This is the substring you got, right? And then, but now what you can do is you can move J because here you already have C and D frequency is not going to be impacted because the frequency map that you'll have, right, of your substring is D will doesn't matter, D is not there, so you can move further. So you J move here, right? So your J comes here. Now E is also there, so J further moves O, right? So from here J I will still be in there. J can move till O because O is must. Other words are not needed, right? So O is 3, 6, 9 means 8. So J is there till 8. So simple 12 minus 8 plus 1, which is nothing but your 5. 5 is a minimum. That's a simple thing. Just you have to match, if you give the frequency map, then it becomes pretty straightforward for you, right? So just a simple solve. If you just this frequency map you keep and just whatever you have here, right? Basically, in short, right? So I computed a frequency map. So, yeah. So this a TFT, and then I did a sliding part that I was explaining and just matched it. If both matches, that's fine. And basically, if both matches, it's fine. Once you found key, you found one of the substring, you try to minimize the length. That's the whole point. This is the first when it's not there. J, I, J plus 1 and starting mode, then you just return a substring. And this is a point where I was minimizing. You are moving the J pointers. You have to slide also, right? Sliding for the, here you have to move character by character so that you know the frequency. It is not like whatever you need, right? You are not moving in J unless it's not, you'll move J only when it's not impacting your frequency, right? Which is required. And at the end, just you return a minimum starting point, you have minimum length, you have, and just return. That's all. Yeah, I think this is a pretty much straightforward, and I think this covers pretty much the concept of the sliding window. I think, yeah. Yeah, and the time complexity for this is the O of n into 256, which is nothing but your string characters, which can be small case, uppercase, or any other, right? So I have just, for the safer side, I've kept it to 56, and assuming this O of n equal, this is a very constant C, and space will also be of 256, and I am not considering the substring length, else you can consider that also as a space. Substring length here. So then it becomes whatever is the maximum, right? Yeah, I think that's all from my side in this video. Hope to see you soon in the upcoming video where we'll discuss more about the different concept. As sliding window, we have covered a good enough problem now. We'll try to see which concept we can come up. We'll try to see some interesting problem, yeah, with some different concept on the either on the graph or a greedy, yeah, mainly. We'll see which one we are able to make the video and share it. Thank you once again, and hope to see you soon. And please like, share, subscribe. Yeah, I think.